Hi all, this is an exam questions related to simple harmonic motion year 2011-12 PSPM. You can see full of simplicity in this simple harmonic motion. For the first part A, what is meant by simple harmonic motion? You may refer to my previous video of simple harmonic motion which stated this definition. So simple harmonic motion is a periodic motion about a fixed point without energy loss. For the section B, an object of mass 50 kg suspended from a spring undergoes a simple harmonic motion with a period of 6 seconds. Calculate the angular velocity of the motion. So the angular velocity of the motion can use omega equals to 2 pi f. 2 pi by f is 1 over period. So 2 pi 1 divided by 6 seconds. So you will get 1.047 radius per second, or 1 over 3 pi radian per second. For B Roman 2, what additional mass should be added to the spring so that it oscillates with a period of 8.0 seconds? Everyone knows that for the spring, period equals to 2 pi square root of mass over k, or T equals to 2 pi d power payung makan ketupat. So T is proportional to square root m, where 2 pi and k is remain constant. So T proportional to square root m. So mathematically, T1 square root m1 equals to T2 square root m2. So T2 over T1 equals to square root m2 over m1, which is equals to square root of m2 over m1. Given T1 equals to 6.0 second, T2 equals to 8.0 second, and mass 1 equals to 50 kilogram. So with these values, you can find the mass 2. So from this equation, 8 over 6 equals to m2 over m1, 50 kilogram. So m2 equals to 88.9 kilogram. So the added mass equals to 88.9 kilogram minus 50 kilogram. So we get 38.9 kilogram. Simple like a bubble without giving you any trouble. So we able to get the added mass to the spring, which is equals to 38.9 kilogram. For section C, a 200-gram object is connected to a spring and moves along the x-axis in a simple harmonic motion about the origin. The position of the object is given by x equals to 0.5 cos in bracket 0.4 pi t minus 0.25, where x is in centimeter and t in seconds. Calculate the frequency of the motion. By comparing the given equation and the general equation for the displacement x, which is given here, x equals to a cos in bracket omega t minus phase angle. When we compare these two parts, we can see the omega equals to 0.4 pi, which is equals to 2 pi f, so that the frequency is 0.2 hertz. Next, for Problem 2, velocity of the object at t equals to 2 seconds. You have two options. One is by using the formula, another one is by using the calculus method. If we use the formula, this is the way. So the velocity of the object is equals to positive negative omega square root of a square minus x square. So from this formula, omega is given, the answer is given from this section C1, which is omega is 0.4 pi, and the amplitude is given to the question. A is 0.5 centimeter. So for x displacement, we have to find the displacement at t equals to 2 seconds by using this equation. So by substitute t equals to 2 seconds in this equation, you will be able to get the displacement x, which is equals to negative 0.319 centimeter. So you can use the calculator to proceed. Make sure you change the mode to radian. So 0.5 cos 0.4 times 2, 0.8 pi minus 0.25, so answer is negative 0.319 centimeter. You can leave it in centimeter or you convert to meter also can, no problem. Feel the trail without any seal to reach the beautiful hill. So now we can substitute all the values into this formula. Then finally you will get the velocity of the object at t equals to 2 seconds, which is positive negative 0.48 centimeter per second or 4.8 times 10 to the power of negative 3 meter per second. Simple like a bubble without giving you any trouble. Or you can find the velocity of the object at t equals to 2 seconds by using the calculus method. When we differentiate x into t, we will get velocity, which is equals to negative omega a sine in bracket omega t minus phase angle. So we know that omega is equals to 0.4 pi, amplitude is 0.5 centimeter. for the displacement x at t equals to 2 seconds. So you will get the answer negative 0.48 centimeter second, or negative 4.8 times 10 to the power of negative 3 meter per second. For section 3, acceleration of the object at t equals to 2 seconds. You can use the formula for the first method, which is a equals to negative omega square x. At t equals to 2 seconds, x equals to negative 0.319 cm. You can get this value from Roman 2, this part. For t equals to 2 seconds, the displacement x is equals to negative 0.319 cm. So omega is 0.4 pi and x equals to negative 0.319 negative. Finally, you will get 0.5 centimeter per second square, or 5.0 times 10 to the power of negative 3 meter per second square. Or we can use the calculus method. From the displacement x, we differentiate x into t to get the v, and we differentiate v into t to get the acceleration, which is equals to negative omega square a cos in bracket omega t minus phase angle. So we substitute all the values accordingly and we will get exactly the same answer, 0.5 centimeter second square, 0.5 centimeter per second square, or 5.0 times 10 to the power of negative 3 meter per second square. Piece of cake, we just need a cup of coffee. Total energy equals to kinetic energy maximum. So kinetic energy is half m v squared, the v should be maximum. V maximum is a product of amplitude and angular velocity. So by substituting all the values accordingly, m, omega, and the amplitude in meter, so that you can get the final answer in joule. So this must convert to meter. So the final answer is 3.95 times 10 to the power of negative 6 joule. Or you can use another formula of the energy store in the spring, which is energy store in the spring equals to half kx square. For total energy, x will be amplitude, where amplitude is maximum displacement. So the amplitude, substitute here in x. So by substitute all the values in this formula, for the k constant, you can use this formula, and this formula is a process or the flow from t equals to 2 pi square root of m over k. So you substitute all the values accordingly and you will get the similar answer, 3.95 times 10 to the power of negative 6 joule. The x square here should be amplitude square, and this E is the total energy. So we successfully answered this question. Thank you for watching this video. Thanks a lot and thank you to the Lord.